Angular spent years carrying a specific reputation. Developers saw it as the framework for slow-moving legacy enterprise development, a heavy, rigid monolith that demanded strict adherence to complex rules. But between Angular 16 and 21, the framework was systematically dismantled and rebuilt. The engineers stripped away the legacy rendering engine, completely ripped out the old testing suites, and removed the heavy abstractions. What remains is a lightweight, Zoneless, ahead-of-time compiled ecosystem explicitly optimized for high-performance progressive web apps. To understand exactly how this modern architecture functions, we are going to look at an AI-powered video tutorial portal. By breaking it down, we can examine its three core layers: services, UI components, and the compilation pipeline. We will reverse engineer this video portal. This will allow us to see how Angular constructs its modern scaffold, how the new reactivity engine isolates state changes, and how the production pipeline minimizes the final code bundle. This transition shifts the framework's focus from runtime-heavy execution to a build-time optimized system that enforces specific architectural boundaries. The foundation of this architecture relies on standalone components and tree-shakable services. By declaring a service with provided in root, Angular ensures the service is available globally, but can still be cleanly eliminated during the build if no component actually imports it. This 3D network diagram represents hierarchical dependency injection. A central API service projects logic outward, snapping perfectly into front-end components, creating a secure conduit. Through this, a user logs in via Google OAuth 2, exchanging an ID token for a secure JWT. To apply this token consistently, functional HTTP interceptors act as the primary architectural checkpoint. Whenever the video player requests a stream, the interceptor catches the outgoing request and automatically fuses the JWT bearer token to the header, keeping components free of authentication logic. If the backend returns a 401 unauthorized response, that exact same interceptor silently catches the error, pauses the request, and triggers an automatic token refresh sequence before the user notices a delay. While interceptors handle outgoing data, functional route guards, specifically can activate fen and can match fen, serve as the strict perimeter defense for the user interface itself. Before a user can navigate to a lazy loaded video route, these guards verify the authentication state. If the user is logged out, the framework blocks the request before the component or its module even begins to initialize. This strict scaffold guarantees that secure state management is handled entirely at the framework level. It completely decouples security logic from the user interface. Every single-page application faces the same mechanical problem. It has to know exactly when and where underlying data changes so it can update the DOM. For years, Angular solved this using Zone.js. Every time a user clicked a button or data arrived, it triggered a massive, invisible shockwave of computational checks across the entire application. This split-screen diagram illustrates Zone.js. By patching browser APIs, it forces coarse-grained change detection, checking the entire component tree from top to bottom on every event. This expensive full tree traversal required manual on-push optimization and caused constant errors on unaffected nodes. In Angular 16, the framework introduced the modern solution to this problem: fine-grained reactivity through signals. Signals operate on mathematical precision. A writable signal actively notifies the framework when its value updates. For derived state, computed signals recalculate only when their specific parent signal changes, creating a direct dependency line. When an update requires an external action, developers use effects. For example, when a video progress signal updates, an effect silently triggers an API call to log the watch history. The contrast between the two models is stark. When a signal updates, the framework directly modifies only the specific DOM node bound to that data. It bypasses the rest of the component tree entirely. Real-world benchmarks reflect this efficiency. Migrating an application from Zone.js to Signals yields a 30 to 80% reduction in CPU usage. Signals replace reactive workarounds with targeted precision, allowing the framework to update the UI without performing component-wide checks. With the reactivity engine optimized, we have to look at how this code is validated and packaged for deployment. Historically, the developer pipeline was bottlenecked by legacy testing suites like Karma and Jasmine, which relied on executing heavy browser environments just to run simple unit tests. In Angular 21, the framework officially adopted Vitest. This shift was driven by its native ECMAScript module support and seamless Vite integration. Vitest enables rapid component validation and precise HTTP mock testing. By operating without the heavy browser overhead, its watch mode executes 10 to 20 times faster than the legacy tools. In the ahead-of-time compilation phase, raw component blocks enter a press and are precompiled. This completely excludes the bulky Angular compiler from the final bundle. Simultaneously, the build optimizer slices off any unused components through a process called tree-shaking. The resulting optimized application is then wrapped in a service worker using the Angular PWA package. The service worker is governed by the ngsw config file, executing the PRPL pattern: push, render, precache, and lazy load. This ensures the video portal maintains core functionality even when the user goes offline. The resulting pipeline creates a deployment artifact where framework overhead is restricted to the specific logic needed by the application. This isometric stack layers UI on top, signals in the middle, and security at the base. Requests travel down through route guards and interceptors, validating the JWT. Stream data returns, updating a writable signal that pulses up to instantly update the video progress bar. And this entire stack operates as a tree-shaken, ahead-of-time compiled service worker, executing efficiently and independently of the main browser thread. Angular has stripped away the legacy weight. What stands today is a strict, zoneless, compiled architecture designed